Well, with us today from all the way across the country in Corning, New York, from the Corning Museum of Glass is Helen. How are you today?
I'm wonderful. How are you doing
I'm
today?
excellent. I do really want to thank you for taking some time to join us this afternoon because I think this is very cool. The Corning Museum of Glass is well known, and what you do there is essentially take a product and transform it. So talk about, first of all, what is glass and how is that created?
Yeah, so I'm here in the Corning Museum of Glass amphitheater. It's one of the places that we do daily demonstrations with glass blowing. But what is glass? It really is a non-crystalline solid. It has molecules that are just sort of all jumbled up, so it has qualities of both liquids and solids. But if you're looking at glass, it really is a solid. Solids like ice and quartz have molecules that are arranged in very regular, predictable patterns, and that was something we call a crystalline structure. So when you're looking at quartz, for example, you go to break it, it'll cleave really cleanly along that clean line. But with glass, those molecules are randomly moving around, and so as they seize into place, they seize into very unpredictable, jumbled, random ways. So that's why it's called a non-crystalline structure. It doesn't have grid patterns to that, its molecules. So plastic, wax, rubber, those are examples of other non-crystalline structures.
So we know that glass is made of sand, but how do you take that sand? Like how hot does that have to get in order for you to be able to work with it then?
Yeah, so glass is made of sand, but it kind of depends on the kind of sand and the things that you mix with it to create the types of glass that you want. So we'll talk a little bit about soda lime glass because that's the most common type. But even sand by itself, sand can have a lot of other components with it. So if you go to the beach and you scoop up some sand, you're going to see little rocks and other things that really wouldn't make nice glass. So we're looking at the most refined version, and that's going to be silica sand. Now, silica sand, in order to get it to melt, takes about 3,000 degrees, just above. So that's pretty high. So we tend to add a flux. Flux is lower melting temperatures of materials. And so with our sand, we start out with the high quality silica sand. It needs to be at least 95% silica to be able to even have it melt into glass. And then we add a flux like soda ash. And soda ash will lower that melting temperature down to a much more reasonable 2,000 degrees rather than 3,000. And then what you add to that mixture as well would be limestone. And limestone is going to be a stabilizer. It's going to keep that chemistry from melting in water or being affected by the environment. So sand would only be about 74% of that percentages of the total ingredients, but you vary those. You change the flux that you use, that'll change the properties of the glass. So things like boron added would give you a borosilicate glass, which doesn't expand and contract. Or lead is another addition that can be added, and that adds a beautiful clarity to the glass. So lots of different ways you can mix materials together to create various glass for certain products.
Okay, so the kids will be able to understand the qualities of glass and the different materials you're putting in there. How do you affect the color? Because kids will associate glass in the different colors, but how do you get certain colors of glass?
Yeah, so color is generally imparted from some sort of metallic oxide. Really, most things on the periodic table. So if you're looking at iron, that's going to give you green glass. I actually brought a couple little things with me here to show you. But iron oxide, it looks very red in the bottle, but once it's melted in with glass, it gives us this beautiful light green color. So it's not going to work like paints will. You can't use a dye or anything that would end up burning up in the chemistry. So we're using things like cobalt for dark blue and copper for light blue color. So different metallic oxides mixed in with those raw materials of the silica sand, soda ash, and limestone, and they melt that into the furnace all as one, and that will impart color. But even the way you fire a furnace can change those colors slightly. So there's a lot of chemistry and a lot of perfect timing to get that perfect color.
Okay, so you were just talking about the furnace, and you said we need to get that to 3,000, and then by adding materials, you get it to 2,000 degrees. But other than the furnace or kiln that a lot of students would be more familiar with at schools, what are some other tools and techniques that you use on a regular basis at the museum?
Well, here at the museum, we mostly use our furnaces, and that's what's other side, right behind me, the big gray thing. So that's about 1,000 pounds of glass. So that's what we use for our 2 daily demonstrations. But even within the demonstration, we use torches to help melt glass and be very specific in the way that we can heat in very small areas. And we also have a demonstration of flame working here at the museum. So they mount a torch to the table and then introduce tubes and rods into that torch head to be able to melt and make small objects or hollow objects from there. So you can make hollow objects in kilns, as you mentioned, doing things like casting and fusing, or you can use the inflation and making glass blown objects, or work on the torch to make both solid and hollow objects.
All right, well, Helen, we've got the basics now, but then what we're going to do is we're going to move into another area. But as far as the Brilliant Color exhibit, can you tell us a little bit about that?
So we have lots of resources here at the museum, and right now we have a beautiful show called Brilliant Color. And in the late 19th century, early 20th century, there was really a boom in color that was happening around the world. And that really was correlating with the invention of synthetic dyes. So prior to that, it was a lot of natural materials that would create various colors in home goods and fabrics and things like that. Well, in that late 19th century, we start to see synthetic dyes take over, which encouraged a lot of industries to start adding more color to their repertoire. And of course, glass definitely wanted to be involved. So this Brilliant Color show really talks about glass chemistry, the artistic developments that happened around the time. There's examples of batch books and things that are just such a rare thing to be able to see. So it's a beautiful show. Lots of beautiful objects, very unusual glass objects and combinations of colors and new developed chemistries and things like that. But yeah, it's definitely a great addition to our museum this summer.
So the Brilliant Color exhibit goes until January, and hopefully you can see Helen when you're out there at the Corning Museum of Glass. We'll be back with more right after this.